All right, guys, we'll be working down this right-hand column, and it wants me to find the domain of each function. Okay, so on number 5, all we have is a polynomial function, 2x squared plus x minus 5. Okay, so notice it's not like we have a rational function where you have a fraction like in 6 and 7. You just got a polynomial function. So understand that I could put any number at all in there for x, and it'll spit out a y value for me, okay? So the domain right here is all reals. Okay, that's the easiest way to do it, okay? You could do it in interval notation if you wanted to, okay? So we could say from negative infinity to positive infinity, like that. Okay, I would still choose just put the capital R there. Okay, or technically you could do it in set builder. We could say all numbers x such that x is in between negative infinity and positive infinity, and x is a real number. Okay, so there's 3 different ways you could do that. Obviously, this is the easiest way. It's all real numbers, so just put the capital R there. Okay, now we go to number 6. Okay, now here's the problem here. Okay, any number that'll spit out an undefined value at us, we have to get rid of. And you say, okay, well, when is a fraction undefined? Well, it's undefined when the denominator is equal to 0. Okay, so I have to start with what numbers make the denominator equal to 0 and then throw them out, okay, of what the possible domain would be. Okay, so we start here and we say, okay, set x squared minus 100, okay, equal to 0. And we have to solve that. So this is a difference of squares. Okay, so I could factor it as x plus 10 times x minus 10 equals 0. So obviously x equals negative 10 and x equals positive 10 get thrown out. Okay, so these guys right here, we have to throw them out of the domain. Okay, so these are throwaway values. Okay, other than those 2 values, we could put any other value for x whatsoever in there. Okay, and it would spit out a defined number at us. The only time it's going to be undefined is when x squared minus 100 is 0. Okay, so our domain, okay, let's see. We could say interval notation. Okay, so I could go negative infinity up to negative 10, and obviously I don't want to include negative 10. Then I could go negative 10 to positive 10, and I don't want to include 10, and then I would go 10 to infinity, and then we just union all these guys, like that. Okay, so that's one way to do it in interval notation. Okay, if you want to do it in set builder notation, we could say all numbers x such that, well, x can be anything other than 10 to negative 10, so we say x does not equal plus or minus 10, otherwise x is any real number. Okay, me personally, I like set builder there, okay, on that one. Okay, mainly because it's just a little quicker. Okay, that's about it. Okay, then we go to number 7. Okay, now number 7 is very similar to number 6 because, again, you have a rational function. Okay, rational means fraction. Okay, so I've got a fraction of polynomials. Okay, so the only way that this will be undefined is if the denominator is equal to 0. Okay, otherwise any other real number, okay, will spit out a defined y value. So we've got to figure out what numbers make that denominator 0 and throw them away. Okay, so we take this x squared plus x minus 72 and set that equal to 0 and solve. Okay, so this is going to give me x plus 9 times x minus 8 equals 0. So it's going to give me x equals negative 9 and x equals 8. Okay, so these guys right here are your throwaway values. Okay, we need to throw those away. Okay, other than those 2 values, anything else will work. Okay, so our domain, okay, let's move this up. Our domain, if I do it in interval notation, we go from negative infinity up to -9, but we're not going to include -9. Then we'd start again at -9, not including it, and move all the way to 8, okay? And we don't include 8, so that's why I have a parenthesis. And then we start back up at 8, and we go all the way to positive infinity, okay? And so we union those guys together, like that, okay? That's interval notation. Okay, or I could go set builder notation. So we say all numbers x such that x does not equal -9 or 8. Otherwise, x can be any real number. Okay, once again, I like set builder notation in that one too, although there's nothing wrong with interval notation. Okay, that'll wrap it up.